In this video, we will consider fall factors and the importance of maintaining a high anchor point when using shock-absorbing lanyards. Even at low levels, these types of lanyards can be very effective at minimizing the distance and consequences of a fall should the worst happen. Fall factors help us identify the best anchor points and understand clearance distances. They're a theoretical measurement of the severity of a fall. In other words, the higher the number, the potentially more severe the fall. The basic calculation is fall distance divided by lanyard length equals fall factor. This is very evident when looking at a full factor 2 scenario. The user has now climbed a full lanyard length above the anchor point that they're using. So we'll be free falling twice their lanyard length as a minimum. Notice the increased shock absorber deployment required to dissipate the higher forces that have been generated in this fall. Although a fall factor 2 is sometimes necessary when climbing, in general, it is seen as bad practice. Now we see an example of a high anchor point attachment, which is close to fall factor 0. The difference in full distance and therefore reduced forces generated results in a shorter shock absorber deployment, which highlights the benefits and importance of trying to always maintain a high anchor point. Myth-busting clearance distance requirements are always based on the worst-case scenario, which is a full factor 2. If used correctly, the calculations show that even at a height of 3 meters, shock-absorbing lanyards like this can be an effective method of minimizing the chance of the user hitting the ground and sustaining serious injuries. In summary, the greater the fall factor, the larger the clearance distance that is required. The example in the video shows the realistic clearance distance required between the climber's feet and the ground for 4 factor 0, 4 factor 1, and 4 factor 2. This distance also includes the safety margin. The biggest benefit of a high anchor point attachment can be seen when measuring the free fall distance and the length of the deployment.